Once again, you're welcome to my YouTube channel. In today's video, I'll be giving you some basic things you need to know about carbon as an element. In the periodic table, let me start with the drawing. Group 1, we have group 2, group 3, our group 4, our group 5, our group 6, group 7, and group 8. So here will be my hydrogen, here is the helium, here is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Here is neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and here is argon. This is the element I'm talking about, carbon. Now, if you look at carbon as an element closely, it belongs, this is my period 1, my period 2. So carbon belongs to period 2 and group 4 in the periodic table. Please, there's something I want you to know about the periodic table. All elements in group 1, they have the valency of 1. That means they have 1 electron in the atmosphere. All elements in group 2, they have 2 electrons in the atmosphere. All elements in group 3, they have 3 electrons in the atmosphere. Group 4, they have 4 electrons in the atmosphere. 5, 6, 7, just like that. And all elements in this group, they have 8 electrons in the atmosphere. Now, if you look at this closely again, that means you can say carbon has 1, 2, 3, 4. From my explanation, carbon has 4 electrons in its outer shell, which is had 4 valence electrons. If you look at this closely, please, there's something I want you to take note of. Carbon is tetravalent in nature. All elements in group 3, they are trivalent. All elements here, they are di, while all the one you are having here, they are monovalent. So let's come back to carbon. We said carbon is tetravalent rather in nature. That means carbon has the ability to form 4 different bonds. I repeat, 4 different bonds. So carbon can form a bond here. It can form a bond here, it can form a bond here, it can form a bond here as well. But this bond can only be possible if carbon reacts with another element. And the kind of bonding that will take place must be covalent. Must be covalent in nature. In chemistry, there are 2 kinds of bonds. It's either they are bonded covalently or electrovalently. So we have covalent bond and we have electrovalent bond. Now, the bond that deal with the transfer of electron from one atom to another, talking about the transfer of electron from forming a cation and another one again, the receiver, called the anion. The kind of reaction that is formed here, this is a plus, while here is a minus. So the kind of reaction that is formed here, this is what we call electrovalent or ionic bond. But the one whereby there is a shared electron between elements of same or close electronegativity. If their electronegative value, they are close or they are same, the kind of bonding that takes place there is called what? Covalent bonding. And we have different kinds of covalent bonding. It can be polar, it can be dative bond, it can be hydrogen bond. All these ones I just mentioned, and they are under covalent bond. So carbon is a very good example of an element that undergoes covalent bond. So the bond that will form this tetravalency of carbon is called covalent, not electrovalent. Please take note of that. Now let me come back again. Like what I said the other time, carbon undergoes the kind of bond that will present the carbon is covalent. But please look up. A bond, this is what I want to take note of, is equals to 2 electrons. That means for a bond to be formed, 2 electrons must be present. I repeat, a bond is equals to how many electrons? 2 electrons. That means 2 bond or a double bond is equals to what? Yeah, you are correct. 4 electrons. Then what about for a triple bond? 3 bond must be equals to what? Yes, you are correct. 6 electrons. This is something you need to take note of. Please take note of this. A single bond is equivalent to 2 electrons, double bond is equivalent to 4 electrons, and triple bond is equivalent to 6 electrons. That's to say, for bonding to take place, now look at this side. Let's say carbon reacting with a hydrogen. I'm just doing a sketch work. Hydrogen has one electron in the atmosphere, it's a group 1. Carbon has one here, 1, 1. Carbon has one, let me draw it here. So in this bonding, a hydrogen atom will come to this place, it will bond to this place. And this carbon is not stable. Remember, there's something called the octet rule. For hydrogen to be stable, it must have the total of 8 electrons. And for the octet of for hydrogen to be stable, for carbon is 8, while for hydrogen is duplet. That is for all the period 1 element. The laws they undergo is duplet law, why the duplet rather, why for the other groups, period 3 and period 4, what they undergo is the octet. Now look up again. We have hydrogen here. If you look at hydrogen now, hydrogen has its 2 electrons, but carbon has 1, 2, 3, 4, 5. It's not stable. If another hydrogen should come here, this hydrogen is stable, this carbon is not stable. If another hydrogen should come here, this hydrogen is stable, carbon is not stable. For another one should come here before this carbon can be stable. I don't know if you get what I just said. So that means a carbon plus 2 molecules of plus 4 hydrogen, 1 carbon atom reacting with 4 hydrogen to give us this. And from what I said the other time, I said a pair of electron, let me rephrase, 2 electron is equals to 1 bond. So I will come like this, I will write it like this, I will put a hydrogen here, this one here, I will put a hydrogen here, I will put a hydrogen here, I will put a hydrogen here. So this is 2 electron, 2 electron, 2 electron, and here is 2 electron. So please take note of this kind of reaction. If you have something like 1, yes, hydrogen, let's say, now I just want to explain something to you with this double bond so that you understand better. This hydrogen here is stable because it has 2. Now, this structure here is not correct. Let me start from there. I want to prove to you why this structure is not correct. This hydrogen has 2 electrons, this hydrogen has 2 electrons, this one has 2 electrons. But this carbon is supposed to have 8 electrons for it to be stable. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is not stable. That means I have to remove 1 bond. 1 bond is supposed to be here for it to be stable. But if here must be double, then one of these hydrogen will have to disappear, and one of these hydrogen will have to disappear. So now let's count. 1, 2, 3, 4, 5, 6, 7, 8. Carbon is stable. 1, 2, 3, 4, 5, 6, 7, 8. This one is very stable as well. And if I should double this, you already know what I'm going to clean. I'm going to clean 1 hydrogen. I'm going to clean 1 hydrogen. So for carbon to be stable, carbon must have the maximum of 8 electrons. Sorry, not even the maximum. Carbon must have 8 electrons. And hydrogen must have 2 electrons because it obeys the duplet rule. Helium must have 2 electrons. Lithium must have 8 electrons. Beryllium 8 electrons. Boron 8. Carbon 8. Nitrogen 8. Oxygen, fluorine, neon. All of them, they are what? They are 8 electrons in the atmosphere for them to be stable. Now, now take a look at this. If you look at this nitrogen atom, we have this is ammonia. And if you look at this already, this one is stable, right? Very good. Let me come back to this concept. This one here is taking part in the bonding. The electron here, they took part in the bonding. This one, they all took part. So we call all these ones as bonded pair. Bonded pair. Because they are the reacting electrons. They are the ones that these are the electrons that are reacting. Why? In this case, I can also write it like this. We have 1, we have 2, we have 3. Hydrogen will be star. Will be a cross rather. So in this, you call 1, 2, 3 as what? These are the bonded pairs. These are the bonded pairs. Why this one here does not take part? So we call these lone pair. And when this bond reacts with a proton, and if you react with a proton, we are going to form what we call ammonium. And this kind of reaction, this very one here, reacting with this, we call this a dative bond. I believe that you have done chemical bonding before, so you have a better idea on how these those stuff look like. But what I want you to know especially is that a single bond is equals to 2 electron, double bond is equals to 4 electron, triple bond is equals to 6 electron. And again, carbon belongs to period 2 and group 4. So I believe that if you have an idea on this and the kind of bonding that carbon undergoes in organic chemistry, the kind of bond that carbon undergoes is called covalent. And please take note, organic chemistry is study of carbon compounds, except some compounds. This question might come back in your Waec exam or your Jamb exam. Please take note. Carbon, organic chemistry is the chemistry of carbon compound or carbon and its compound, but there are exceptions. We have oxides, which are CO2 and the CO. We have the cyanide. We have the metallic carbonate, and we even have the carbide, metallic carbide. All these ones here, they are exception to organic chemistry. Oxide of carbon, they are exception. Cyanide, so they are exception. Carbonate, they are exception. And metallic carbide, they are also exception to the study of organic chemistry. Thanks for watching. Do well to subscribe. Thank you.